And now we move on to the last part, the fourth and final part of the presentation. Excuse me a bit. So we will be touching a bit into the more advanced terminology of data science, including but not limited to machine learning and artificial intelligence. So let's start with AI, which is the broadest concept among the three terms, machine learning, AI, and data science. AI refers to the development of computer systems that can perform tasks typically requiring human intelligence. So essentially, we try to replace a human job with that of a machine. These tasks include learning, reasoning, problem solving, perception, and even language understanding. So in essence, what artificial intelligence aims to do is to create machines that mimic the human behavior and thought processes. Now, machine learning or ML is a subset of artificial intelligence, is included in that field. And it involves the use of the statistical methods to enable machines to improve a task with experience. What this means is that with machine learning, instead of the traditional way of programming, which means that the programmer must write every possible if condition to do a certain action, if then. In machine learning, this isn't necessary. And instead, the computer itself is making the predictions and decisions based on the data it's presented with. So machine learning algorithms automatically build a mathematical model based on the sample data, or as we say, training data, to then make predictions or decisions without the need to be explicitly programmed to do so. And finally, data science is the interdisciplinary field that uses scientific methods, algorithms, processes, and systems to extract the knowledge and insights from structured or unstructured data. It involves a blend of various tools and principles to discover hidden patterns in the raw data, which may not be visible at first glance by a human. Data science needs to be stressed out. It's not exclusively about AI nor ML, but uses various techniques from both of those fields, along with others from statistics to data analytics, computer science, and many more. What is the relationship between all those things, AI, ML, and data science? We can think of the ultimate goal of AI as the need to create systems capable of performing tasks that would typically require human intelligence. So both machine learning and parts of data science contribute to achieving this goal by enabling machines to learn from data and make intelligent decisions. Again, as we said, like a human who's in the same position. Machine learning is the primary means in which we achieve this artificial intelligence. It provides the methods and algorithms that enable computers to learn from data and make AI possible. And data science can be regarded as the foundation that provides all the knowledge, techniques required to analyze and interpret complex data. It supports both ML and AI by preparing and processing that data, discovering the patterns, and providing insights that can be used to train a machine learning model. Without this kind of science, it would be challenging, impossible even, to create effective AI systems. So in essence, all those terms are closely related and overlapping, but each one has a different scope and focus. AI is the overarching goal of creating intelligent machines. Machine learning is the means with which we achieve that, and data science provides all the foundational techniques used when we want to extract knowledge necessary to fuel AI and machine learning algorithms. Now let's talk a bit more about what the machine learning processing is specifically. It can be described by 6 or 7 steps. The first one of which is the data preparation. This includes the data cleaning procedures we mentioned and transforming them into a structured format that we can use later on in order to create, at the second step, create a learning data set for use in a training model. We also create a test data set to evaluate the model performance after it's being trained. This step is only performed in case of supervised learning. In the unsupervised learning case, we skip this one because we may not be able to have a test data set to use. In the third step, we go through the learning process loop, specifically the selection part. We have to select a specific algorithm based on the kind of problem we're dealing with. And depending on the algorithm we use, we may have additional pre-processing steps, but we won't go into that here. Then there's the evaluation. We evaluate the selected algorithm performance, and if we find it suitable, we keep it on. Otherwise, we have to repeat the learning process with a new model and algorithm. The fifth spell is the model evaluation. We test the solution we decided on the test data, and judging by the performances of learning data, we can decide whether we will carry on with this model or have to change it again. And finally, we have, after all these steps are completely successfully, we move into model implementation, which means that we implement the model into the data that we need, the real world data that we need to assess. Example of that could be big data, for example. This is the steps from data preparation, but just see this for reference. I won't go into them right now. So we have the learning data step, a bit more thoroughly explained. Again, just for reference, we can see that first we select the algorithm, we fit the data into the algorithm, we feature the selection and reading, the model learns based on those data, we evaluate the model, we may have to perform overfitting or underfitting, depending on the case. And finally, we iterative improvement. So we improve with each repetition of the cycle. And this, the analogy cycle for testing the data. Again, just for reference, this is a bit technical stuff, so I won't go into that too much. Let's carry on with the learning process loop, the selection. Again, we see that the key aspects of this step are the algorithm selection, the model hypothesis. So we formulate which models might work best based on our previous experiences as an expert, based on knowledge from other domains, etc. And then we prepare a selection of models to test and see which one fits best. So we experiment with different models, and using a validation set, we can fairly assess the performance of each one and decide which one is best. Same with performance evaluation using different metrics, statistical methods, which are a bit too technical for this presentation. With June. Anyway, we compare the models, and at the end, we can have a feedback loop. So based on the insights we gained from this particular application, we can make future decisions better later on. Again, here, these are the steps of the evaluation part of the model implementation. I won't tire you with much detail. You can find more information about this on the presentation once it's posted. We have the model evaluation steps. So we first assess with the test data. We measure the performance metrics. We cross-validate with techniques such as k-fold cross-validation with anyone with a statistical background. We analyze the errors introduced by the model. We use comparative evaluation. So we compare different models with each other and evaluate them this way. We understand what the model behavior is, which you can adjust based on the evaluation results. And then we have to iterate the same process again and again in order to to improve the model further on. This is not a one-time task, to put it simply. The model implementation now step, also known as model deployment, is where a validated and tested model, after we've done all the previously aforementioned steps, is put into a production environment and used to make real-time predictions or decisions. The key components of this step include the integration, which means embedding the model into the current infrastructure, so it can receive input data, process it, and provide outputs. The automation step, where the inputs processes operate in real time and or batch mode depending on the application's requirements. Monitoring, we have to establish monitoring systems to track the model's performance. We have the performance checks, the maintenance, which needs regular updates, especially in business environments, etc. Feedback loops, we implement feedback mechanisms to collect insights on the model predictions. Scalability is the ability of the model to handle any scale of data at any rate or speed. Security and privacy, of course, making sure that the data is protected and the model is not doesn't lose its integrity. Sometimes we have to develop a user interface for the model so end users can interact with it more easily, even if they don't have the necessary expertise. And this also comes hand in hand with documentation and training. We may need to create documentation for the model we deployed in order to train the staff that is going to operate it and or maintain. So I think with that being said, we have finally reached the Q&A part of the presentation. Again, if someone from the online audience or the physical audience here in our room has any questions, I'd be happy to answer. Hello. Let me check the chat and see one question. You're very welcome. Thank you for listening. And as we come to the conclusion of the presentation, please make sure to fill out the evaluation form on in-class. You may do so by scanning the QR code on the projector from your mobile phones. And later on, you can move on to completing the short quiz in order to receive the final certification of the BETES training project.
Okay, please share the link to the online form, the evaluation form in the chat, please.
Say again, please. I couldn't hear you.
Please share the evaluation form in the chat.
Yes, yes, of course.